Hello, hello. Hello, Jessica. Hello, Nicholas. Hello, Alona. Hello, Andrew. Oh, okay. I'm going to do it that. I'm so psyched to see so much video. It's great. And pictures, which are also great. Okay. Good afternoon, she. Hello, Nicholas. I said that. Good afternoon, Andrew. I love how he says hello to other people besides me. Good afternoon, Catherine, with a spelled a certain. Hello, Alona. Oh, wait, more people come. I'm gonna do this again. Yes, good afternoon, she. Hello, Nicholas. Good afternoon, Andrew. Good afternoon, Catherine. Hello, Alona. Oh, more people. Am I going to keep starting up? I don't know. Or maybe, oh, no. Yes, more people. Okay. Hello, Alona. Good afternoon, Jaylyn. Good afternoon, Catherine. Hello, and good afternoon, Athea. Good afternoon, Manoj. Hello, Michaela. Good afternoon, Zemin. Hello, Nicholas. I think okay, got that. All right. Hello, and good afternoon, Jessica. Good afternoon, Ruby, and everyone. Good afternoon, Lisa. Good afternoon, Eric. Good afternoon. Honestly, you guys, I really think this is the first class where anybody says hello to everyone or anyone besides me. I think it's totally impressive. Maybe it's a new Zoom ethic. I mean, I don't, but totally heartwarming to me. Good afternoon, Rachel. Good afternoon, Elizabeth, and everyone. Good afternoon. Oh, I'm going to do it again. Oh my God, I'm going to do this wrong again. Wait, wait, I'm going to do this wrong again. Now, okay, I'm going to back. It's not Alia. Good afternoon, Alia. No, I'm doing it wrong again. Good afternoon, Althea. So it's not, okay, you're gonna have to correct me again. I know, now this is getting bad because it's like my third time I know, but it's not Alia. I know that. So I want to say it's Alia.
It's Alea.
Alea, what is my problem? Okay, okay, let me just pause for a second because, right, thank you. And by the way, you totally get points for not only putting up with me, but you get points for using your voice again, which is the smart way to do this. What is my, I mean, I do know what my problem is, that there's a word in Hebrew that is like that, that's spelled like that, and that's what's throwing me off. But Alea, why can't I do, I'm going to write this down. Okay, this is really bad. Okay, thank you. All right. Hi, Leslie. I'm not doing this anymore. Wait. I could totally understand Alea saying that she's not doing this anymore. I could understand Alea like just like storming out of the class at this point. I'm not totally sure what Nicholas means, but okay. Oh, maybe he means video? Wait, well, anyway, okay. No, he doesn't. Sorry, I'm going to stay out of it. Oh, okay. But I did see that, Nicholas. All right, I'm going to stay out of it. I'm going to, or you can clarify if you want. All right. See, this is the problem with taking risks. Like, is that I'm failing. Okay. So wait, who else am I? Okay. So I see. Now I'm going to look at the video and see. But wow, no, this class. Wow, there's so much video. It's so great. And oh, I'll even. Okay. By the way, I have to admit right now. Well, I have to admit a couple of things. And, admission is the first step toward diagnosis. First of all, I'm totally behind you guys. I'm sure it's already clear, but let me just make it clear that I know that it's clear. I'm behind you. None of you is behind. Like, I owe you tons of work back now at this point. I'm not saying that proudly. I'm saying it as a confession. I owe you tons of work back. I'm also just saying, so you know, if you haven't gotten things back from me, it's not personal to you. It's not something you've done wrong, and it's not any reflection on your work. It is my fault, and it is universal right now. And the two, and there's no good excuse for it, but the two consolation prizes of me being so behind right now is, one, it means, it means I'm not going to assign anything new for a little while until I catch up. You can still be doing revisions and stuff once you get them back, but as long as you've handed in homeworks 1, 2, and 3, or as long as you've handed in anything that you haven't gotten back, that means you're ahead of me. So cool. Pat yourself on the back and know that, you can focus on other classes or whatever for the moment, maybe not this moment. But the other thing is, there's another thing about me being behind. There was another consolation prize of that. Well, it also just means that I feel guilty, so that you can, like, it's easier to take advantage of me. But There was something else about me being behind. Well, one thing, I tried to catch up a little bit with even just the game assignments, the participation, they're easier to look at and send back to you. And one thing I did notice, and this is the first time, this is the first class where this has come up of any Zoom class anyway, that many of you are showing video like frequently, like more than one day. And so you've resubmitted, oh, excuse me, someone's here. So a number of you have resubmitted the video portal thing, like you submitted it once, you got points, then you showed video again and you submitted again, which someone had asked me about last time, like, can we do that? Or what happens if we do that or something? And I had never had this situation before. So I just riskily said, okay, well, try, resubmit it. And maybe I'll give you the points again. Maybe I'll give you points each time. And for what it's worth, that's what's been happening. Just to be clear, like I wasn't even sure if Google Classroom would allow me to do that. And I wasn't sure how I felt about the idea, but there are those of you in this room who have like showed video once, submitted it, got 8 points, whatever, and then showed video again. And then you just like submitted it again to the same portal. You just like resubmitted the same assignment and said, I did it again, or you listed the dates that you did it. And even though I've never faced this before, and even though the points might skyrocket as a result, right now, any of you who has like submitted video like 3 times has gotten 27 points instead of 9, which means it's a lot of points. Now, at some point, I might have to slow this down because it might get crazy. Like there might be so many points, I don't know, but I'm not. So I'm just warning you that I might have to readjust because I've never had such an embarrassment of riches. And as I'm saying this, I'm looking, there's like 15 videos being shown right now. Now, again, none of this is to shame or punish or criticize anybody who's not showing video. There's 1,000 reasons not to, and I get them. And also it's not to, and remember, if you show video for a little while, that does not mean that you're now trapped and you can't turn it off and go to the bathroom or something like that. Like, because I think that's always a fear. It's like once you're showing video, then I'll notice it once you turn it off. I might notice it in the back of my mind, but it's not like that. Any of you have shown video for any period of time, has submitted it, has gotten points, and those of you who just decided to try to see what would happen if you showed it more than once and submitted more than once, got more than one multiple of 9 points. So right now, it's fair game. Go for it. If all of you keep doing it, then all of you will keep getting tons of points. I'm all for it. Like, again, I didn't even know Google Classroom would let me do that, but it does. So yes. Oh, now this is a good question. I'm just looking if it's private or public. That's a good question. John Ford's question in the public chat, is it 20 points max for each homework? So the simple answer to that is no. Let me give you the slightly more, or this is my brother would say, my brother's so obnoxious. He would go, the short answer to that question is no. And the long answer to that question is no. Okay, that's totally obnoxious. But here's the real deal. Get it? Okay. No, 20 points is not the maximum necessarily for any homework. Here's the real deal. Homeworks are differently weighted. First of all, it's true, the actual standard physics homework, the problem solver homework that we have to get back to in a minute, and we have to start getting faster and faster with, things where you actually have to solve problems and show work, those are generally worth a lot more, certainly each one, than the game assignments. So like the typical first few of those were like 20 points. And then I think maybe one was 20, one was maybe 15. And then train of thought might've been 20 again. I can't remember. Oh, okay. Right. So the standard nightly game homework is only 5 points. A standard problem solving homework can be like 20. But the truth is, as we get moving faster and move thicker, now this is scary. She's taking a picture of, I'm not even going to ask. No, okay. I assume, yeah, no, it's cool. Sorry. As the homeworks get longer, the regular problem solving homework, some of them will be worth more than 20. Some will be worth like 30, 35. I mean, I can't remember off the top. They could be, there's no limit. They could be very long. And with the game homeworks, the typical nightly ones are worth 5. But, the sort of more special ones like showing video or using your voice, those are worth more, like 8 or 9 or whatever. And apparently what we're now finding for the first time is if you submit those multiple times, you can get multiple point values. So right at this moment, I'm not saying that there's any max for either kind. I may have to do something if people start like submitting things all the time. I might have to adjust slightly, but no, there's no max right now, as far as I know. Okay, let me see. Oh, okay, hold on. 1 second. Oh, and I just realized, and I didn't mean to embarrass anybody, I just realized why some people are taking pictures of the skin. Makes sense. Okay, I get it. Okay, so that's the answer to that question. So this is great. So I appreciate. So again, I'm behind you. Please forgive. What we're going to do in a minute is just get back to going over the homework number 1 so that we can move on to homework 2 and homework 3. Again, things will go faster and faster as we go, for good or for bad. Like we're, if I'm boring people, I apologize. It will start getting more or something. But right now we're going to finish up going over homework 1. Also to clarify, this Wednesday, please tell me if I'm wrong. This is what I think I remember. Last Wednesday, we didn't have school at all. Just across the board, we didn't. The Wednesday before that, I believe, please tell me if I'm wrong, but it was 2 Wednesdays ago when I had the weird, like when you just watched a video instead of coming to class, I believe. Is that correct? It looks like Nicholas is saying yes. Okay, thank you. So assuming that's correct, then that means, just to clarify, because I know it's still confusing. Yes. Okay, thank you, Catherine, and thank you, Nicholas. Then that means tomorrow is normal class. Just to, I'm not tomorrow. This Wednesday, just to confirm, like we'll have normal class at 3:05, just like you're having now. Nothing special, nothing weird. The following week it might be weird, but I'll warn you behind that. But just so you know, like normal class this Wednesday. It's my other class that will be strange. Okay, cool. Thank you, Catherine, and thank you, Nicholas. Okay. What was the other thing I was going to, and soon I'll post homework 4, but again, we have to sort of get up to homework 3 before it's even worth my doing that. So as long as you're fine, I'm fine. One last thing, because this one last order of business, let's see if I can. Right. Okay. Yeah. So we're glad to move on. But one last order of business with regard to homework 1, because I know still a lot of you still haven't gotten it back yet. I know that. And again, that's on me. That has nothing to do with your particular work. And I do apologize, and I will catch up. But if and when you get your homework 1 back, or homework 2 or homework 3, if you notice 3-letter acronyms on it, like my comments, like if I write something like DHP or GDP or WIQ, like someone asked about them in the other class this morning, just please note, I'll try to re-explain them. But the honest truth is all those acronyms that I put on your homework, they refer ultimately to a 5-step method that I'm asking and expecting you to start getting used to doing for solving problems in physics. Ultimately, a 5-step method that I expect you to do on exams. I don't think it's anything crazy or wacky, just you might not have been sort of required to do something this specific in chemistry class or something. It takes some getting used to. But my acronyms generally refer to that 5-step method. What I'm trying to say is that when in doubt, last week's class, like if you were either not here or you were not always paying attention, whatever, last week's class, September 20th, is when I explained that 5-step method. I took some time to explain it. I explained all the acronyms that are kind of dumb, but they are what they are. And I explained them in the notes. So the PDF of the class notes from September 20th, as well as the video from September 20th, is when all those, if you ever don't understand something on your homework that I wrote, please refer to that PDF of notes from September 20th and or refer to the video. Ideally, at some point, I'll try to make a typewritten, neater version of that, but I haven't yet. So, but just please know, that's all explained in last week's class. Refer back to that if and when you get homeworks back. Okay, all right. I'm going to start going back over homework 1. There's something in the chat though. Okay, cool. Oh yeah, totally. Okay, great. Jessica's question, totally legit. Starnisha's answer, totally legit, like totally correct answer and totally helpful. Just to confirm, yes, you totally, look, you can totally still make revisions on homework 1, 2, and 3, especially because like I haven't even handed it back to a lot of you yet. You totally can still, every single one of you still has the opportunity to get full points, all the points, whether it's 20, whatever it was, on homeworks 1, 2, and 3, all of you, even if you've never turned in homework 1 yet, like, yes, at this point, you might want to start catching up as well, just like me, but The boom has not dropped on anybody. Even if you never turned in anything for homework 1, 2, and 3, you still have the opportunity to get all of the points, not be penalized for lateness. And those of you who have turned things in and or turned in revisions, please know that I know that. Like, I know that you did. You are still getting karmic recognition for the fact that you are that on top of things, but it is not too late for anybody. I'm going to move on now, but I just want to say, I would say the 3 scariest words in the English language to me, like literally the words that send shivers up my spine in an academic context, in a romantic context, in a political, ethical context, the 3 words that send shivers up my spine are, it's too late. Like, okay, technically it is 2 words. I guess technically that's 4 words, but I can't stand it when people tell me that it's like, when I finally come to understand what I need to do or how to do something or want to do something, and someone says like, no, you've missed the mark. There's no going back. The boom is dropped. Your chance is over. I just can't deal with that. I mean, to me, that's death. So I'm telling you all, that is not, I mean, at a certain point, certain things will be too late, and I'll hate that moment as much as you, but we are not at that point for any of you on any matter in this class yet. We barely started. Okay, cool. Yes, for real, it is the scariest word. I mean, right. And the scariest word is physics. All right. Well, if that's true, okay, fair enough. But hopefully I'm making it slightly less scary. I mean, hopefully, please don't be scared of it. Don't be, or at least be slightly less. Oh my God. Okay, you guys are funny. All right, I'm gonna, oh, that's very, okay, now see, now I'm just like fishing for compliments. It's all becoming cheesy. Everybody's like, yeah, Verbaum, enough already. God, grow up. But I will say this too, on Nicholas's thing, even if he's joking, like deep in my heart, just to say to everybody, if he could even say that, he's probably sort of joking. He's that petrified, probably couldn't make that joke or whatever. But look, I have been very scared of physics in my time. Remember, I'm the one that chose to do with my life, and it has scared the bejesus. I mean, I've gotten some very bad grades in physics in my day. Don't get me started right now. And I've definitely walked into exams in my day where I knew nothing, like, or felt that way, or I looked at the question and I was like, what is this question even asking? And they were high stakes exams. And again, I chose to be there, so I couldn't even blame it on anybody else. I couldn't even be like, why are they forcing me to do this, right? Physics can't, so I sympathize is all I'm saying, but it doesn't have to be that way. That's also what I'm saying. Okay, whoa, okay, all right, I appreciate it, but I'm now getting past the smelling salts, I'm getting embarrassed, so I'm gonna move on. All right, we're all gonna move on. And also excerpt that part out of the video. Okay. All right, so we're moving on. I believe, oh yeah, now you're gonna have to correct me too. This is where I believe we're up to. So we're going again, we're back to homework 1. Again, this will speed up. It will speed up. We will not spend the rest of our lives on homework 1. I promise. And if I were a music teacher, we would not spend the rest of our life on scales, but we would spend a long time on them because they are scales. So I believe in homework 1, I believe that where we got to, oh, cool. Thank you, Starnisha. That's great. Starnisha's like the voice of like truth or something. Well, anyway, thank you, Starnisha. That's number 2 helping us. All right, so this is what we're up to now. Those are the answers, right? Okay, so I believe we're up to part 2. Starnisha saying question 1 and 2. I believe I explained them right at the end of class last time. So just to note, I'm just putting the answers there. Like if you were doing homework, you would give me more than the answers, right? You'd first give me the diagram and the fact pattern at the beginning but you did that at the beginning. And then for each question, you would literally be telling me what is the question. You'd be telling me some general principle or definition that you used to start answering it. Then you'd be filling in the numbers, watching the units, manipulating the algebra, whatever. And then you would get an answer and then you would circle it. But to start speeding up, I'm just saying right now, I believe that we got the answers to those 2 questions. Stop me if I'm wrong. And quick, and so, okay, cool. And I'm going to keep going. So I believe the answers to question 1 and 2 of part 2 were 6 feet and 6 feet again. I'm being a little, they're both positive 6 feet. They're both positive 6 feet. So you could put a little plus sign before each of them if you wanted, or you could leave the plus sign off entirely. I put a little plus sign next to the displacement answer, just sort of to be a teacher, just to kind of remind all of us that with displacement, it could be positive or negative, right? Or even zero, right? Just to remind you, displacement is the vector quantity in physics. It includes not only size, but also direction. So displacements can be negative if, in the case of this problem, if things were going left, we would call them negative. But the answer in this, whereas distances can never be negative. Distances are always positive. It's like, so I just put a little plus there just to connote that like, if that guy had been going left, we would have said negative, but he wasn't, so we didn't. Okay. And then it says, oh, yes. And by the way, okay, I wasn't sure if this was going to happen. The way Rachel just put that exactly right. And oh, I'm just changing the view here. Actually, it's funny. That's an important clarification. Notice the way Rachel said it. She said, for you, like as in me, I guess, right was positive. And she's exactly right to put it that way. Now, first of all, the reason that the answer is yes, like right was positive, is simply because that's what I put in my picture, in my diagram on your sheet. In my diagram, there's a number line at the top, and all the numbers to the right of 0 were labeled as positive. All the numbers to the left were labeled as negative, and that's the only reason. I mean, this is where Rachel has a really important point. There's nothing objective in the universe that says right of 0 always has to be positive. And there's certainly nothing objective in space. Like space is what we call homogeneous and isotropic. There is no actual positive direction in space. There's no actual x-axis in space. You can call this x, or you can call this y, you can call this positive, or you can call this negative. It is a choice. It is up to us. But now, and so Rachel's right to put it like that, like to you, to me, I said right was positive. Now here's the thing though, and this is what we're going to get into in the train of thought homework. Well, like it says at the bottom of the sheet here, like negative refers to direction in physics. It doesn't necessarily always refer to left. It refers to a particular direction. And then it says in horrible handwriting at the bottom here, we must always choose a coordinate system first. This is one of the reasons that it is so important that we put a diagram at the beginning of a problem, like not necessarily for every single part, but at the beginning of a problem, whether I, the questioner, did put the diagram or not, you, the answerer, want to put a diagram, because the diagram is actually where you label choices, where you show what you have chosen to be the positive direction and what you choose to be the negative direction. Any one of you, if you wanted to, you could have presented a diagram, and you could have made a diagram like this. First of all, you could have made the thing go up and down. It wouldn't change any of our math or any of our like thought processes, or you could make it like this if you want. And you could have labeled all the things. You could have put the 0 wherever you want, and then put all the numbers to the left of 0 as positive, and you could have put all the numbers to the right as negative. And as long as you stay consistent with those choices, then all your math is going to work out the same as mine. Your final answers will either be the same or different depending on what the questions are, but everything will be internally consistent and be correct as long as you are consistent. So here's the thing, and we're going to get more and more into this. This is a very big deal in physics. The one good news of physics is we can make many more choices than people realize. A lot more is just up to the user, or up to the experimenter, up to the researcher, whatever you want to say. We get to choose our axes and whether they're positive or negative. That's the good news, is we get to choose. The bad news is, and this is really important, is we don't actually get to choose. We have to choose. It's not like voting. And I'm serious about this. It's a political analogy. It's a little bit dangerous, but I'm serious about this. With voting, like you can vote for this person, or you can vote for that person, or you can like vote to not vote at all, right? Like that is your right as an American citizen. Like, you know, if you're over 18, whatever, you can go to the voting booth and pull whatever level you want, lever, or you can also like not pull a lever. Now, some people may get all in your face about that, and they also might get in your face about what candidate you chose, but that's them getting in your face. Like part of the voting process is that you have a choice to not make a choice. And sometimes that's like a very active, conscious thing that people do, right? That is in democracy. That is not in physics. I want to make this clear that where certain choices are going to come up, like we choose our Yes, I am literally saying this. to John, I mean, I think he's not joking. I am saying that from here on in, positive means one direction and negative means the opposite direction. But whether positive means north or south, or forwards or backwards, or right or left, that is up to the user. By giving my diagram, I showed you how I was thinking about it, and you could take that as a strong recommendation. I mean, when in doubt, you can do it my way if I give you a diagram. But all my diagram is showing you is the choice that I made from here on in. And it's to encourage you and remind you that you have to make a choice. Okay, you could choose to make the same choice I did. Like, I'm not saying it always has to be a really hard choice, but choosing your coordinate system, labeling, like deciding what to use the positive sign for and what to use the negative sign for is actually, it is up to you. And you're going to see that's going to become very important. But you actually do have to consciously decide one way or the other, even if you're consciously deciding to do the same thing I did. But this is one of the reasons that step one in the problem solving 5-step method is DFP, diagram fact pattern. You have to give a diagram because you actually have to show how you are thinking about positive and negative directions from here on in. And this is really not so yes, you do have a choice, but you don't have a choice about whether to make the choice or not. You literally have to make a choice. Let me just see if I answered. I don't know if I answered so yeah. All right. Now in this case, I made the choice that right was and let me just be even more specific. There are standard choices that are common and habitual and seem to make sense, such as yes. When you were in third grade, number lines, generally they put they made the right positive and they made the left negative. Or in a math class, generally with your axes, with a grid, with a Cartesian coordinate system, with a graph, generally we make this way positive and that way negative. But that's a choice. And similarly, we generally make up positive and down negative. But you're going to see very soon in physics that a lot of times it's much more convenient to call down positive, not negative. Like when everything's falling down and there are nothing going up, you end up having a ton of negative signs that just become a big pain in the butt if you don't just choose to make down positive. So what we do in physics is we make the choice that is the most convenient for solving that problem, which means we actually have to think about convenience. And that sometimes seems inconvenient to people. But once we think about it, then things get more convenient. So, all right. So I'm babbling too much, but yeah, this is an important thing, actually. Okay. I don't know if, but yeah, if you're following my definitions, wait, sorry, I'm looking at Alona's. Sorry. If you're following my definition. Yeah. No, that's a really great. I'm glad Alona's pushing slightly on this. Basically, so my most honest answer, and again, this is all we're all forgiving right now. We're all getting used to each other and to the method. So I'm not saying I would slash and burn your points right now if you didn't. But ultimately in physics, you have to specify at least once. Ultimately in physics, even if you think it's clear, you still have to specify. But I just mean once. I would mean at the beginning of the whole problem, you would provide a diagram. And part of the reason and your diagram won't look exactly like mine. But one thing your diagram will definitely have is positive and negative being specified. Even if it's the same as mine, even if you don't think it's unclear. Even if you don't think it's unclear. Yeah. Oh, and again, if you didn't do that this time, I'm not saying I punish you or send you to jail. But ultimately, the one thing that is not clear in physics is direction until we specify it. Or put another way, it's so important that we don't want to leave any chance for lack of clarity. So I'm not saying for every single part of the problem, but at the beginning of the whole problem, you do. Yeah. Okay, great. Okay, cool. I love this class. Thank you. That was major points right there for the, okay, cool. All right. So I'm going to go on. Oh yeah. All right. So this is just a reminder. I mean, someone asked this in the chat in the other class, someone said in the homework, I received these comments. What's the deal? Just a reminder. I did it. I'm not saying I won't explain it again. And I'm not saying, I'm a big believer. Nobody hears anything the first time. Okay. I mean, that's another thing. That whole tone of I said that on December 1st. like once while I was sneezing. So how could you not know that now? Like, no, I mean, obviously everybody has to hear things a million times in order to hear them. But since we are recording these things, and since I am like giving you my notes afterwards, just to remind you, if you see anything on your homework, like a 3-letter acronym, and you're like, what is this? Thank you. I appreciate it. Okay. More where that came from, but man, or I think I knew who you meant. I think I might still not. But anyway, yeah. So if you see anything in your homework that you don't understand, I will try to re-explain it. I'll try to make a typewritten sheet, but please refer to the notes from September 20th and/or the YouTube video. There's basically 5 acronyms that stand for the 5-step method here at the bottom. And then there's a couple of other acronyms too, like WWW, which means like what, why, where, from. And that kind of means you skipped a lot of steps, et cetera, et cetera. But okay. So that's that. Just to remind you. Okay, right. Okay. So next page. All right. So now we go to question 3, part 2. Here I'm dragging it out again. I'm just trying to show, like, I think many of you probably got the right answer to this very quickly, and that's cool. And that means you do understand the physics. Like, I think the answer to question 3 is positive 3 feet per second. The average speed equals 3 feet per second. I think that is the answer to question 3, but I'm showing you all the work that I am kind of expecting you guys to do. And again, the easier the problem is, and the more all this work seems like a waste of time, then first of all, the more it's not a waste of time practice for harder questions. And also, to be honest, if it really is that easy, then writing out all of this stuff, I mean, it might seem like a waste of time, but at least it's not hard, right? You're just like writing out stuff you already know. So, you know, roll with it that way. But anyway, so I wrote like refer to previous page for diagram and givens, because and you can do that too. I'm not saying you have to write the diagram and the givens out for every single part. I mean, they haven't changed throughout this whole thing. So just refer to previous page. And you don't have to say that every time. I'm just saying it here because we haven't been together for like a week. Then I wrote the question, right? From t equals 3 seconds to t equals 5, what is the average speed? So I'm just like notating in the right-hand side, like that's step number 2. What is the question? Now, as we progress further and further and get into more technical questions, writing out the question will be easier. Like often we'll just write like V equals question mark, but we don't really have symbols or equations for these English terms really. Like average velocity, we have a symbol for it. It's V with a bar over it. Displacement, we have a symbol. It's like X minus X naught. But like speed and distance are still kind of the English ideas on which we're building these mathematical ideas. So I'm still kind of in English here. So the question is, what's the average speed? So I wrote average speed equals question mark, right? That's then note, again, I know this is it's old news to a lot of you, but then note what's my next step in the problem solving method. After I've written out the question, now I do GDP, like not gross national product or not gross domestic product, but GDP stands for general definitions and principles. No, this is a step that people skip a lot. And it's like they always skip it when they know what's going on. But if they don't know what's going on, then they're always like, I have no idea what's going on. And what I want to say is, if you have no idea what's going on, freaking write down a definition or a general principle, because that will start triggering what's going on. So in other words, what I'm saying is, notice the question is asking, what's the average speed at blah, 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 blah. So like we're looking for numbers, right? We are looking for some number for that average speed, but instead of diving straight into numbers and starting to do number crunching or plugging and chugging or looking for a formula to plug in, no, just note, oh, the question's asking for average speed. So let me first note what average speed always means, like regardless of whether it's this problem or not. Let me just write. In other words, don't look, what's the formula? What's the formula? There's no magic formulas. There's definitions of terms in the questions, which then eventually turn into equations, which people call formulas. But formula makes it sound like it's like some black magic thing that you just like have to memorize or you get from the pharmacist. It's not. It's just a definition of the terms in the question, which, by the way, is also why here we're in English, just trying to show you that. And then we're going to make it more and more symbolic. We're going to substitute symbols for these English words, but I want you to see that that's all that's happening in the math. It's not black magic. It is just symbolic expression of ideas that are already in our head and that are already in. And my wife thinks it's black magic, but she just brought me like a cup of coffee. So we're going to go with her view on that. It is kind of black. No, now I'm all, right. It does seem like black magic until until you like look in the hat and see that the rabbit has been in the hat the whole time, and we're just pulling it out sometimes more quickly than we'd like. So oh my God, I'm like so defensive now that my wife just said that, even though that was hilarious. Okay. Or because it was hilarious. So I wrote down, so notice the question is, what's the average speed? Like equals question mark. So then I write average speed equals triple equal sign equals distance over time, right? And that's always true. Even if I'm losing sight of this particular question, I'm writing down a truth and then I'm going to make it relevant rather than writing down something relevant and trying to make it true. That latter thing is what people always do when they panic. They don't realize it, but that's what they're doing. And when you say it that way, you realize that doesn't make any sense. You can't make something true that isn't, but you can start with something true and then you can just particularly apply it. Anyway, so I write down average speed, triple equal sign, distance over time, right? And then, so that's GDP, that's step number 3. Then now I get into step number 4, doing what most people consider to be the work. What does that mean? It means I'm PAW, particular application and work. I'm applying the general definition to the particular situation here. I'm saying, oh, we need distance over time. Okay, so in this case, the distance is 6 feet. The time equals 2 seconds. So now I can put one over the other. Now I can plug in the numbers, so to speak. See how much has gone on before I even plug in numbers, though? That's kind of what I'm trying to say. So now I write average speed equals 6 feet over 2 seconds. That's PAW, particular application and work. It's step number 4. A lot of things happen before. So then I go to the next page. And I reduce the fraction, whatever. I watch the units. And what do I get? I get my final answer, FAC, final answer circled. Step 5, average speed equals 3 feet per second. Notice all this was really an evolution from a triple equal sign to a double equal sign. When you're really doing physics right, that's all that's ever happening. You're evolving from a triple equal sign to a double equal sign. You're evolving from something that is generally true to something that is particularly relevant, from a triple to a double. And the more you actually trust this method, the more you can actually apply it to problems where you think you don't know how to solve them, or you might even think you don't even know what they're asking. But okay, anyway, that's the answer to that. So then I circled it, highlighted, whatever. That's the answer to question 3. I'll start getting a little fast. Oh yeah, so now I'm going to pause for a second. I'm going to keep moving on, but obviously stop me, any of you. I mean, I'm just figuring that, it's time to move tracks, to make tracks for a lot of you, but stop me at any time. But now we're going to go on to part 2, question 4, and I'm going to start skipping steps. And I'm a little worried about this, but in my notes here, because I feel like you're probably getting it and you probably want me to move on, I'm going to maybe here and there start skipping steps and just putting down answers as I see them so that you can see if you got your answers right. But please remember, when you're doing homework for me, you got to do all the steps. And why? Because it's practice. And if you forget to, then you just resubmit until you do them all. But it's all practice for the exam, where you totally have to do all the steps. But if I start skipping now, refer back to earlier examples for the steps. Okay, so I'm going to turn the page. Okay, yeah. So now we get to question 4. So question 4 is, what is the average velocity for that time interval that I now forget, for the time interval from t equals 2 to t equals 4. So I should have written down the question, but I didn't because I'm trying to move on a little bit. But now I skipped straight. So maybe I'll make this clear. So I went straight to GDP, to step number 3, right? Yellow. Right, so this is, just so you know, this is step number 3, GDP. Right, I wrote down the general definition or principle applying to average velocity. Now, average velocity is very much like speed, but it involves direction. It's the vector, and I hope I've told you this before, but like distance and speed are scalar quantities, right? If I never said that, or if you didn't ever write that, please write that down. Like distance and average speed are scalar quantities. They are pure magnitudes, pure sizes, whereas displacement and average velocity are vector quantities. They involve both magnitude, size, and direction, right? Those are the more rigorous, more precise, more ultimately scientific concepts that we ultimately deal with more in physics, these vector quantities. So we do start symbolizing them now, right? Average velocity is symbolized with V with a bar over it. The V means velocity. The bar means average. And average velocity is change in position, i.e. displacement, i.e. the difference between where you are now versus where you were then, over change in time. Like it's a change in point in space divided by a change in point in time. It just simply is the simplest, most balanced ratio of space interval to time interval that we can conceive of. That's what average velocity is, right? But then notice, because, so it is balanced. It's like x minus x naught over t minus t naught. What I'm trying to encourage you here is, this is the only equation we have right now, but it's a pretty powerful equation. We're going to do a lot with it. It's the only equation we have right now, but I'm trying to get you to see that, yes, it's an equation, but it's not a formula. It's just a definition. Like, we never discovered this average velocity equation in a lab. We're never going to discover in a lab that it has any flaws or mistakes. It is, if this equation is correct at all, it is 100% correct for all time. Unlike, and that's not right, unlike like PV equals nRT or something. Like, and I don't mean to bust on chemistry. I mean, some of my best friends are like, I love P equals nRT. I use it all the time. But that's a very different, that's not a triple equal sign equation. That is a discovery, P equals nRT. And it's like sort of true, but it's not perfectly true. It just generally works out to be true enough to be useful. It's an empirical discovery, P equals nRT, or other things like that. It's a triple, that's a double equal sign. This is a triple equal sign. It is not something we discovered. It is just a shorthand. We're just saying from now on, if you put space interval over time interval, we're going to call that average velocity. So if it's true at all, it's always true. But furthermore, since t sub 0 always by definition is 0, we don't usually have to write it, right? So I usually cross it out and just leave it as 0. So often this equation will look unbalanced, and then it'll look like something you're just memorizing, x minus x naught over t. I'm just trying to show you it's not. I mean, it just looks unbalanced because one of the terms is 0. Okay, anyway. So because it's symbolizable, we now have an equation for it. This is what I mean by general definitions and principles. We generally, at this stage of the game, we write down an equation, a definition that applies. It'll look like an equation. And then we start plugging in or arranging it or whatever. So in this case, so I skipped the step, I skipped Paul, but in this case, the displacement was 6, the time was 2. So I plugged them in and I got, again, by coincidence, the same answer as before. It's a different question, but it's the same answer. That's not a contradiction. That's like, what is 5 plus 2? 7. What's 4 plus 3? 7. That doesn't mean those were 2, or even better. What's 5 plus 2? 7. What's 7 divided by 1? 7. Those are 2 totally different questions, right? They mean totally different things. They happen to have the same answer. That does not mean that they're the same question. Same thing here, right? The average velocity happened to turn out to be the same as the average speed because this dude was always going in one direction and always going in what we're calling the positive direction. So it turned out that they were the same, but they are 2 different questions. Okay, so that's the answer to that. I'm going to pause for a second. You can look at the rest for a second. We just post messages coming in left and right here, or chat things. Okay. So then the next, and what this ends at 4:20. Okay. So then the next question, question 5, what's the average speed from t equals 5 to t equals 8? Yeah, all right, same method. I mean, I'm going to start moving. Ask me if there's any questions, but there I do the same thing. I write down average speed equals total distance over total time. The total distance in this case from 5 to 8 equals 9 feet. Oh, and how did I know that? Because, I looked at the problem. It went from -5 to +4. Maybe I should have probably written that down. If I were doing the homework, I probably would write that down. But so we get the average speed is 3 feet per second. Again, same answer, but for totally different reasons. All right, so that I'm going to move on. Stop me, but that's, yeah. And again, if you're getting these answers right, but you're still losing, good. That means you understand. I mean, I'm just, whatever, I'll shut up. Okay, so that's I'm glad, I hope you're getting, but if you're not getting these answers right, hopefully this is explaining things. Okay. Then question 6, right, again, we're doing the same thing here as in question 5, only now I kind of have equations because we're talking about displacement and velocity. So average velocity is displacement per time. The displacement is 9 feet. I got that answer from one of the previous questions. Often it goes like that in physics. So I get 3 feet per second, technically positive 3 feet per second again for this. I'm going to keep moving. If that's cool, tell me if you want me to go back to this page. But so that's part 2, question 6. Then we go, hello. Okay. Part 3, question 1. Oh yeah, okay, now. Oh yeah. All right. So this is part 3 now. It's literally labeled like questions where you have to think. Okay, that's a little bit obnoxious, and actually my former colleague wrote that. I didn't write that. That's a little bit obnoxious. I mean, why? It's true. You do kind of have to think to do these questions now in part 3. But first of all, you had to think in the other ones too. Like you didn't, I don't know, we didn't like emote our way through the other questions. It wasn't like I feel like having a cheeseburger and the answer is 3 or whatever. But obviously what it's really, presumably what it's trying to say is you have to think a little bit more for these questions. And that is true, I think. The questions coming up here. Now, again, I'm going to say, some of you might have gotten one of these questions wrong that we're about to do now. Some of you might not have gotten the answer at all. Many of you might have gotten the answer and you might have gotten it right. And you might even be like, this is not that big of a deal. What are you getting at, Yavin Brown? Well, let's see. I mean, fair enough. If you got it right, great. I'll say for this question, question 1, part, someone's here. Sorry. Okay. For question 1, part 3, I am going to do a lot of work here to show, because I do think no matter what, I think this question does involve a little bit more work than the prior questions. But straight up, I will say the answer to question 1, even though I'm going to do all this work just so you can put your mind at ease or whatever, I believe the answer to part 3, question 1, I believe the answer is positive 1 foot. Like yeah, I believe that's the answer. Like remember the question here for question 1, part 3 is at t equals 7, at the 7th second moment, at that mark, when the clock strikes 7, exactly where is the instructor? At what position? That's the question right now. I believe, and notice how I could just notate that, like the question is at t equals 7, x equals question mark. Okay, that's the question. I do believe the answer is going to turn out to be positive 1 foot. If you got that answer, then you're doing something right and you understand something, even if you didn't show all this work that I'm about to show. If you didn't, then we're going to see how to get it. So what do I do? Okay, first, even if I, what a lot of you might have done to get this right, you might have like visualized it. And I totally respect that. You might have sort of done pictures in your brain, and you might have done them really fast, where it might even be the case that if I said to you, oh, good, you got the right answer, but can you show me how you got it? You might legitimately, some of you be like, I don't know. I just like, I can see it. Like, what do you want from my life? Like, I don't know. He was going like this and he was going like that. So we like by there, he was there. I believe that some of you can think of it that way. I do. I believe that some of you are that fast and that smart, and in many cases, smarter and faster than I am. I believe that you can see something so accurately that at first you can't even explain why you can see it. But I also believe that it is my job as a physicist to show you how to break that down. Like, even if you think I just did it, I don't know what I did. Our job is to find out what you did in order to get it. Because again, at some point in physics, we can't just do that. We can't just visualize in our mind that fast. We need a method. And the truth of the matter is, I know I keep saying this, but even if we visualize something super quick in our mind, that does mean we're smart, yay. But it just means that our mind raced through a bunch of visualizations really quickly. It doesn't mean that there was only one visualization. It means there were steps that our talented brain was able to race through really quickly. Our job is to break down, to stop, step back, zoom in on our brain, zoom in on that movie, slow it down and see what steps our brain did go through. It's not an insult to our intelligence to do that. It's more like an admiration of our intelligence to do that. But we need to do it for those moments where we don't feel quite so intelligent. So I'm going to say, even if you did visualize it, you were visualizing something. And I'm going to tell you now what I think it was that you were visualizing. So what we do is to see what our brain did is we do the method. First, I write down a general principle or definition that applies to the question. Now it's going to get a little tricky because the question asked for position. The question asked, where is the guy at t = 7? It didn't ask for average velocity. But the only general definition or principle I have so far is one for average velocity. That's the only equation I have. So I'm writing it down. At worst, maybe I'm going to have to do something, or maybe at worst, but it is true. If this were an exam, by writing down the definition, the triple equal sign for average velocity, I am getting points right there because it is not wrong. It is right, even if I don't quite yet know what to do with it. But I'm never going to know what to do with it unless I write it down first. So I do. Right? And I notice, this is not an equation about position, but it certainly involves position, right? I mean, position is X. It's contained in the right-hand side of this equation. So I start to rearrange it. Like, duh. I mean, I know you all know algebra. I'm not trying to tell you like you've never done this before, but I am saying to do it. I'm saying I wrote down the one definition of the one equation that I had, average velocity, and then I start rearranging it to solve for X, right? I mean, I'm just translating into English here. So I rearrange it, X minus X naught equals V times T, right? That's just algebra. But that means it's definitely right, as long as I didn't make a mistake. I mean, meaning it's not only sometimes right. If it's right at all, it's always right. And so in English, I'm just saying, if average velocity by definition is displacement over time, then displacement is equal to average velocity times time. In other words, final position minus initial position equals average velocity times time. And final position is what we're looking for here. So this is all valid what I'm doing, right? I mean, this is kind of like saying distance equals rate times time, which you hear your whole life, right? In some ways, all of physics is one big extrapolation and expansion of the concept distance equals rate times time. It's just that what we're saying in physics is, depending on what rate you're talking about. What we're really saying in physics is, well, distance does equal rate times time. If by rate you mean rate of average speed, then it does. But if by rate you mean like average velocity, then displacement equals rate times time. Or if by rate you mean instantaneous velocity, then we're going to need a whole other thing. Or if by rate you mean acceleration, which we're getting to next, then you need a whole other thing. So in a real way, physics is really all about rates. It's all about which rate equals what, when, what. So the rate we have here is average velocity, E equals displacement over time. Therefore, displacement equals average velocity per time. Therefore, I'm rearranging to solve for X, right? And notice here, right? So I get here. So I'm just doing algebra, but notice I'm just doing algebra. I have not plugged in a single number yet. Someone's here, sorry. I have not plugged in a single number yet. Again, this is where I'm trying to break some old habits with some of you. And with some of you, I'm trying to break old habits because you don't feel so confident. So you need new habits. And others of you, I'm trying to break old habits because you might feel too confident right now. You might be relying on old habits that can only take you so far and can't take you as far as we need to go. I mean, everybody it can be different personalities at different moments. But the old habit of thinking that showing work means diving in and plugging in numbers, don't do that. Don't plug in numbers until the last possible moment. That's like, if nothing else, that's the new thing I'm trying to teach. Start with general, no problem. Cool, no problem. But thank you. One second, sorry. I'm trying to say, start with truth, move to relevance. Do not, and that means start with letters and general equations and manipulate them until you have what you're looking for isolated, then plug in numbers. literally, that is the way to postpone the loss of points as long as possible if you're ever going to lose points. So and again, this is the thing that people don't do a lot. A lot of people will plug in the numbers and then rearrange. Don't do that. I mean, it will work sometimes, but it won't work for as long as you might think. So I'm solving for X. I'm solving for what the last position is at the end of time. Then I start plugging in numbers. Now notice the numbers I plug in here. Well, I'm just looking at the time. Okay, so I plug in now X naught equals -5. I plug in T equals 2. And I plug in average velocity V equals 3. A little bit interesting. That's a choice there. Again, here what I'm doing now is I'm putting an equation form in an algebraic form, something that many of you might have just visualized. And again, that's fine. And if you can express all this in a bunch of diagrams, God bless you. I'm not saying it has to be math looking. It could be diagrams, but it is a series of them. What I'm saying here is I rearrange the equation to realize, like, I don't need any new formulas. I don't need new physics knowledge. All I need is what I already knew, the definition of average velocity. I rearranged it to solve for position. That's what the question's asking for, position. And I know I can do this because everything else is known. Like, right, I mean, there's one unknown, position. Everything on the right side of the equation, V, like this and this and this are all known. Okay. But let me be careful. They're known, like average velocity V is known to be 3 feet per second. Why? Because I just figured that out a couple of questions ago, like one question ago, when we figured out that at a certain stage of this problem, the instructor advanced 9 positive feet and did so in 3 seconds. Therefore, we reduced the fraction and we got 3 feet per second is the average velocity. Now notice, there are other average velocities in this problem as well. Like at the beginning of the problem, well, for example, the average velocity for the entire experiment. If you look back in your notes for question 4, I think it was, for the entire experiment, the average velocity was -9/8 feet per second. In other words, -1.125. You might recall, or you might see in your notes, for the entire 8-second journey, when the instructor went like, the average velocity for all of that was -1.125, but I ain't using that number here. Also, the average velocity for like some middle section that we saw before was like 2 feet per second or something, but we're not using that. I'm specifically using 3 feet per second because that was the average velocity for the last segment of the journey, the segment that includes the time that I'm looking for. Like I'm looking for where is the instructor at t equals 7 seconds. So I'm applying an average velocity that applies to that moment in time, right? Like at t equals 7 was during that last bit of this whole thing. During that last bit, the instructor was traveling at 3 feet per second, right? Right, because we just figured that out a question ago. So now to be consistent then, so what I'm saying is, oh yeah, so it says, I am choosing, this is where choices come into physics. I am making a choice. It's cool that I'm allowed to make a choice, but I have to recognize that I actually have to make a choice. I'm basically saying I can get position as long as you tell me average velocity. And then what you're saying is, well, there's different average velocities to choose from. Like, I don't know which one to use. And I'm saying, use the one that's applicable, that's relevant to the question that's being asked. We're being asked about something that's happening during the last 3 seconds. So let's use the average velocity that applies to that. But and I'm sure many of you are like, duh, I get it. But then I'm saying, if we're going to do that, if we're just going to look at the last 3 seconds, then it's almost like we're starting our stopwatch right at t equals 5. We're now choosing to just pay attention to start our data collection right at t equals 5. That's really what's now becoming our new initial moment, right? T equals 5. So at that, right? So if you remember that x naught means position when t equals 0, when you start your stopwatch, initial position, please note again, the initial position for the whole entire experiment was +4. But now I'm zooming into this last experiment. It's a choice, just like, quite frankly, the whole experiment was a choice in the first place. Really, what was probably happening is this instructor is just spazzing out and zigzagging back in front of the classroom, like forever, just doing it. And then we walked in at a moment, start our stopwatch. We walked in when the instructor happened to be at x equals 4. It's always up to us. Data is just the world. The world is just spitting out data all the time. We choose to start collecting data at a certain time. We choose to stop collecting data at a certain time. We choose to start collecting data at a certain space, et cetera, et cetera. It's about, we have to make choices of what is our perspective on the universe. How are we taking it in? So if we are just going to now look, it all sounds obvious once it's explained, right? If you break things down into small enough steps, then hopefully each step is so obvious that it's boring. Like, I don't really want to be boring any of you now, but I kind of do, right? Like, hopefully, because I've broken this down into tiny enough steps, each step is like, oh yeah, duh, oh yeah, duh, right? And that's what's up to you to do ultimately, is you want to break down these problems into small enough steps that each step is like, duh. The catch is, because you're all successful, smart science students, and I'm not saying that sarcastically, what you're used to, or what I was used to when I got into physics anyways, I was used to being smart enough and fast enough and having huge amounts of work in all my classes, that I was used to sitting down to do some work like bio or chem, and knowing it was going to take me hours and hours, but knowing what it was going to look like when I started. Like, basically, from my experience with bio and chem, and I'm saying this like with all respect, my experience with, or in prior math classes, were like, when I sat down to do the work, I knew where it was going. I just had to do it. If I had to solve a problem, like, I knew how to start it because I kind of knew how it was going to end. I might not know the literal answer until I did it, but I knew the procedure, and now I just had to do it. And then there'd be like 49 of those problems, like exercises 1 through 89 odd or something. So the intimidating thing was how freaking much I had to do in bio and chem or whatever, or math. But physics isn't that way. The thing is, with physics, often you sit down and you don't actually know where it's going until you sit down. And so and there aren't that many problems to do, as you can see already, or that many equations to choose from. There just aren't. Physics isn't about what's complex. Physics is about what's simple. But simple turns out to be hard for many of us because we're used to sitting down and thinking that we know where something is going before we begin. So then we have the confidence to begin. In physics, you often don't know where it's going when you begin, but you have to begin anyway. So what I'm trying to tell you is the things to do at the beginning to get yourself going, even if you don't know where it's going. So I'm saying you begin by making a choice. Choose what the experiment is, what the coordinate system is, what is positive, what's negative. You make those choices, you spell them out, and you write down average velocity equals displacement over time. You rearrange. Now we start plugging in the values. We're just plugging in values, but no, this is the easy part. Now that we've made all these choices, I'm literally saying at the beginning, like, so I'm not memorizing. Don't memorize x naught equals always means first position of the whole experiment. No, it means first position when you start paying attention. And here we're paying attention to a different segment of the experiment. So the initial position for the last 3 seconds is -5, right? That's where he is at t equals 5. And then I'm saying t equals 2 because I'm going to measure from there all the way to t equals 7. Like, right? Like, we want to know where. Right? We want to know where we are 2 seconds after t equals 5. Why t equals 5? Again, because that's when this last constant velocity segment begins. This segment where we actually know the velocity and can use it. All right, so I think I'm belaboring this point. So x naught equals -5 feet, t equals 2 seconds, v bar equals 3 feet per second. That's the key information that this is all relying on. So now I plug in, or now I flip the page. Now I plug in, right? And so technically it's, so I am plugging in. I'm plugging into this. This is not a new formula. Don't memorize it. It's not a new equation. Don't memorize it. It's not like we now have two formulas that you should know. It's also not like, don't say, well, this is unfair. Like, how was I supposed to do this question? I mean, he never told us that formula before. No, no, no. Oh, this is all on question. This is all good. This is all on question. Sorry, this is all my work for question. For question 1 of part 3. Oh yeah, so 2, that's okay. I mean, these are good questions. What you guys are, right? So where we got the 2 from, and maybe that is the trickiest. No, I didn't divide it. Okay, good question. Where I got the 2 from, I'll show you, is because I'm choosing. What I'm trying to say is I'm choosing to solve this problem. I'm choosing just to look at the last segment of from t equals 5 to t equals 7, because, so I didn't actually divide time. This is a great question, but where I got the 2 from is I'm saying if we want to know where the guy is at literally t equals 7, like that's what we want to know. Where's the guy at t equals 7? I'm saying what t equals 7 is really 2 seconds into the last segment of this whole experiment. Like I'm restarting my clock in my mind. I'm starting the clock of my mind at t equals 5, because at t equals 5 is when the instructor starts going back across the number line at like t equals 5 is the very, let me start again. This whole experiment really has 3 parts. There's the first part where the professor goes like this from 4 to -5. Then the next part where the, oh, okay, cool. Okay, cool. Okay. So is there, right? And this is the trick. This is why I think this question requires thought. Like, I don't think any of these are dumb questions. This is why I'm spending so much time on this. Like this, what I'm trying to say in the long run is this question, well, now to go back, to get the final answer of +1, right? If you look at this last page of everything I'm doing, I am just plugging into an equation, which is what people often think physics is. I'm just plugging into an equation. But if you really, so it seems easy by the time I get to this. I mean, I think you'll agree, like I'm plugging in 3, I'm multiplying by 2, and I'm adding -5. So I'm getting 6 plus -5, which equals +1. But what I want to say to everybody, I mean, like definitely Starnisha and definitely John, but like everybody, is if you just wrote this down on your homework, or if I just wrote this today in recitation in class, I think that'd be unfair in both of our, because it makes it look much easier than it actually is. Because the real question is, first of all, where the heck did I get this equation? I never taught you this equation before. You might say like, wait, I didn't know we were allowed to use that equation. I didn't know we were expected to. Like, what kind of nonsense? And what I'm saying is, no, actually, that is not a new equation. It's not a new formula. It's an algebraic rearrangement of the one equation we have. And yes, what I am expecting from here on into physics is if we have an equation, it's an equation. It means both sides are equal no matter what order you write it in. So it's knowledge, it's a definition. So I am saying from here on in, it is expected that these equations are very rich and powerful. It is up to us to, okay, that's a great question, Andrews. I'm going to answer it in 1 second. Let me just finish this babbling thing that I'm doing right now. And I am watching the clock too. So number one, I am saying it is expected in this class that once you get an equation, I expect that you can manipulate it any way you need to solve for anything you need to. And it is your job to do that. And my advice to everybody is manipulate the equations before you plug in numbers. It will look, you have to get used to the fact that this will look like we have tons and tons of equations. We don't, we're just doing tons and tons of algebra on very few equations, number one. But then number two, if you just looked at this last page, it would look, yeah, all right, I'm totally going to answer. Okay, these are good questions. But let me say now too, if you look at this, it just looks like plug and chug. But where did I get these numbers from? What I'm trying to tell everybody, and I think this is kind of going to answer John's question and Andrew's question. I'm going to look at their questions more specifically in a second. But what I'm saying is, if you believe me that this is how we're going to solve, like, because we're looking for X, but we know V bar, we know average velocity. If you believe me that that's what we're doing, then we have to realize we know V bar, we know average velocity, but there's many different average velocities that apply to this whole experiment. There's the average velocity going this way. Then there's the average velocity going this way. So, sorry. Am I skipping? Wait, I totally forgot. Oh, am I saying this wrong? Wait, am I doing this wrong? Did I do this? Wait, actually, maybe part of the reason for the question is, wait, did I misremember the numbers? Hold on 1 second. I might have misremembered one of the numbers, and that may be why 2 people are asking questions. Hang on 1 second. Sorry. And I know this class ends in 5 minutes. I do know that. So we're going to end here. But 1 second. Oh. Oh, sorry. No, I am putting the. No, you guys are right. I think this is why you're asking questions. Hold on. Everything I'm saying about the method is correct, but I think I did put in the wrong. I see. Hold on. I'm totally sorry. And I know we have 4 minutes. Hold on. I may have misremembered the problem and put in the wrong numbers. He goes from 4 to -2. Then he goes back from -2 to 4. So then he's at 4. No, you're totally right. You're totally right. I'm going to look back specifically at Andrews and John's in a second, but you are right. I'm sorry. This should be. You are totally right. Yes. Sorry. And so wait, let me just correct. And this may also apply to what Starnisha was asking. I'm terribly sorry. Hold on. Again, the logic of everything I'm saying is totally correct, but I did put in the wrong numbers because I did misremember the problem. Right. That's confusing. Sorry. No, wait, let me just look at these. We have 3 minutes. So the answer, I'm sorry, is -2, I believe. Again, the logic of everything I'm saying still applies, but it's true. If I'm reading the problem correct, I'm looking at the problem correctly now. So what I'm trying to say to everybody, and then I'm going to look at those questions again. I'm saying we're being asked what's going on at t = 7. That is part of the last 3 seconds of this entire journey. In the last 3 seconds, there is an average velocity. There's a constant velocity, and it's -3. How do I know it's -3? Because in the last 3 seconds, he goes all the way from +4 all the way to -5. Like he moves -9 feet in the 3 seconds. So it's -9 per 3 seconds. That means an average velocity of -3 feet per second. In other words, in that last segment, every second, the instructor retreats, goes to the left by 3 meters. We want, and like there's other numbers that apply to other segments, but we're just looking at that segment now because we want to know where he is at t = 7. That really means we want to know where is he 2 seconds into that last journey. So like right at the beginning of that last journey at right at the beginning of that last journey at t = 0, he was at +4. So that, and he's moving -3 every second. So he goes from +4 to +1 in the first second. And then he goes another -3 all the way to -2 in the next second. So let me just look in the, so I think that's why John and, sorry. So this, yeah, so Andrew's totally right. Thank you, Andrew, for the correction. That's totally, again, the logic of what I'm saying is right, but I totally miscopied the facts of the problem. So Andrew's totally right. John Ford is totally right. Starnisha, totally right. So I apologize to you 3, and thank you for bearing with me, and thank you for bringing up the questions you did. So hopefully it's more clear. So thank you, Andrew. So Rachel, so wait, so my bad. But so the answer, and no wonder. So thank you for hanging in and paying. I wasn't doing that on purpose as a trick, but the whole time I was saying +1, it was that I was misremembering the numbers. I'm sorry. These are the correct numbers. This is the way to do it. If you got -2, then it means we're all on the same page. Is everybody okay? I mean, so, but thank you again, Andrew and Starnisha and John. and Rachel. Hope. So wait, we're just going to go. And so the answer is -2. That is the answer. My bad, but very good people. I'm going to open up a portal for corrections or something like that. But I'm good to go. If you guys are good to go, I'm going to hang out for 2 minutes if there's any more questions or anything, but just keep on, but again, good job. Thank you. I mean, seriously, and I'm embarrassed. But the answer is -2. That's where we're ending now. It's 4:20. I'm going to hang if there's any questions or confusions, especially about that. But other than that, goodbye. Thank you. Yes. Have a wonderful. Yes. If you said good afternoon, that counts. Yes. Yes. And thank you. Have a good day. And thanks. Have a good day counts. And goodbye counts. Yes, totally, totally. Awesome. Thank you. Have a good day. Okay. I'm turning. Have a nice, yes, you too. And I'm turning off the recording in case there's questions or whatever. Okay. But bye. Thank you guys very much. Awesome.